The space industry has lived by the same law for decades. The rocket takes off. The rocket performs the task. A rocket burns up in the atmosphere or sinks in the ocean. Each new flight required a new rocket. The cost of a single launch in the 1990s and 2000s ranged from $100 million to $500 million. This made space inaccessible to most tasks. Regular flights to Mars were out of the question, simply because the economy did not converge. Elon Musk asked one question that changed everything. And what if the missile is not thrown away, but returned and used again? In 2015, the first stage of the Falcon 9 returned for the first time and landed vertically on the landing pad. The whole world watched the broadcast and could not believe their eyes. The engineers in the control center were screaming and crying, because it went against everything that the space industry had thought possible in the previous 60 years. But Musk didn't stop at the Falcon 9. Because the Falcon 9 is an intermediate step. The real goal was always different: Mars. And for flights to Mars, a fundamentally different rocket is needed. More powerful, fully reusable, and capable of performing hundreds of flights without replacing key components. This is how the Starship project appeared. Starship is a two-stage system. The first stage is called Super Heavy. It is one of the most powerful rocket boosters in human history. The height of Super Heavy is 71 meters. The diameter is 9 meters. 33 Raptor engines are installed on board. Each engine develops a thrust of about 220 tons. The total thrust at the start exceeds 7,500 tons. For comparison, the legendary Saturn V rocket, which sent astronauts to the moon, developed a thrust of about 3,400 tons. Starship is twice as powerful. The second stage is the Starship itself. The height of the ship is 50 meters. In conjunction with the first stage, the entire system reaches 121 meters. It's taller than the Statue of Liberty. This is higher than most skyscrapers in an average city. And this structure should not just be launched. It needs to be returned. Both parts. And preferably quickly. Because it is the rate of reuse that determines the economics of the entire program. This is where Mechazilla comes in. The official name of this system is Orbital Launch Mount, combined with quick disconnect mechanical manipulators. But people and SpaceX itself call it Mechazilla, by analogy with the Japanese monster Godzilla. Only mechanical. The tower stands on the Starbase launch pad in Boca Chica, Texas. The height of the tower is 145 meters. Two massive steel manipulators are installed on the tower. They are called chopsticks. That is, chopsticks. Because outwardly they resemble them. Only each such stick weighs several tens of tons and is controlled by hydraulic drives with a force sufficient to hold a multi-ton missile at the moment of capture. The principle of operation of the system is as follows. After the Super Heavy completes its task and separates from the second stage, it turns around and begins a controlled descent back to the ground. The Raptor engines engage several times for braking. Onboard computers and the navigation system constantly adjust the trajectory. A few hundred meters before the tower, Super Heavy enters final entry mode. The fall speed is dampened to a minimum. And at the calculated moment, the turret manipulators open and grab the missile by special steel pins, which are called grid fin attachment points. They are located in the upper part of the Super Heavy case. The entire capture maneuver takes a fraction of a second. The computer makes a decision to capture in real time based on data from dozens of sensors at the same time. Why is it important from an engineering point of view? The traditional method of landing a rocket involves retractable landing legs. They add weight. They take up space. They require maintenance. And the most important thing, after landing, the rocket must be transported from the landing pad back to the launch pad. It takes time, sometimes weeks. Mechazilla excludes all of that. The rocket returns directly to the launch tower. Manipulators hold it in an upright position. The ground handling team has immediate access to all systems. Theoretically, the cycle from landing to the next launch can be several hours. It is this word that theoretically remains the key one. Because the road to a working Mechazilla was long and expensive. The first integrated tests of the Starship system began in April 2023. The first flight ended in an explosion 4 minutes after liftoff. The rocket could not separate the stages normally. The emergency detonation system worked over the Gulf of Mexico. The wreckage fell within a radius of several kilometers from the launch point. A cloud of dust and debris covered the launch pad. The damage to the infrastructure was significant. The second flight took place in November 2023. This time, the separation of the steps was successful. But both stages were lost. Super Heavy exploded over the bay. The Starship lost its orientation and was also undermined by the emergency flight termination system. Nevertheless, the engineers received a huge amount of data. And each failure provided information that could not be obtained in a laboratory setting. The third flight in March 2024 showed further progress. Starship reached a suborbital trajectory for the first time and performed a controlled re-entry over the Indian Ocean. The Super Heavy was lost again. But the trajectory and behavior of the systems became increasingly predictable. The fourth flight in June 2024 was a turning point. Both stages experienced re-entry for the first time. The Super Heavy performed controlled braking over the bay and gently entered the water. The Starship entered the atmosphere at a speed of about Mach 25. The temperature on the surface of the heat shield reached thousands of degrees Celsius. The cameras recorded the burning of part of the heat protection tiles. But the ship withstood and made a controlled splashdown in the Indian Ocean. This was a fundamentally new point in the program. And finally, the fifth flight in October 2024. That's when Mechazilla caught a returning rocket for the first time in history. Super Heavy flew up to the tower. The manipulators opened. And in a split second, they captured a 70-meter machine right in the air. Millions of people watched the live stream. The reaction was the same around the world. This is impossible. But it happened. To understand how technically difficult it is necessary to assess the scale of the task. Super Heavy weighs several hundred tons at the time of capture. Even after most of the fuel has been exhausted, the mass of the structure remains enormous. The missile moves vertically downwards with a residual velocity, which must be completely extinguished at the moment of capture. The positioning accuracy should be units of centimeters. Otherwise, the manipulators simply will not hit the mounting pins. Wind load, changes in air pressure, residual oscillations of the rocket design. All this affects the accuracy in real time. The onboard computer and the ground control system communicate thousands of times per second. And all this happens autonomously, without human intervention in the final phase of capture, because the human reaction is simply not fast enough for the task. The reactor engines that power the Super Heavy are among the most advanced liquid propellant rocket engines in the world today. They run on methane and liquid oxygen. This fuel is called methalox. The choice of methane is not accidental. Firstly, methane gives a higher specific impulse compared to kerosene with a similar ease of production. Secondly, and this is critically important for the Mars program, methane can be produced on Mars. There is carbon dioxide and water ice on the surface of Mars. With the Sabatier reaction, carbon dioxide and hydrogen can be converted into methane and water. Hydrogen is obtained by electrolysis of water. The energy source is solar panels or a nuclear reactor. Thus, a ship that flew to Mars could theoretically refuel there and return to Earth. This is called in situ resource utilization, on-site resource utilization. And without this concept, the Martian program is economically impossible. The second-generation Raptor engine, which is installed on modern versions of the Super Heavy, develops a thrust of about 227 tons in a vacuum. The pressure in the combustion chamber exceeds 300 atmospheres. This is a record figure for serial rocket engines. For comparison, the F-1 engines used on the Saturn V rocket operated at a pressure of about 70 atmospheres. The Raptor operates at 4 times the pressure. This allows for more complete combustion of the fuel and higher efficiency. But this also makes the engine extremely difficult to produce and maintain. SpaceX has learned how to produce Raptor engines on an industrial scale. In 2023, the company was producing about 1 engine a day. This was made possible by the transition to highly automated production and the rethinking of the entire supply chain. Musk publicly set the task of reducing the cost of 1 engine to a level comparable to the production of an aircraft turbofan engine. This is an aggressive target. But the dynamics of the decline in value over the past few years shows that the direction has been chosen correctly. Now about the Starship heat shield. This is a separate engineering story. When entering the atmosphere at a speed of about Mach 25, the temperature on the surface of the ship reaches 1,500 degrees Celsius and above. The surface of the Starship is covered with 16,000 ceramic tiles. Each tile is made individually. Because the hull of the ship has a complex curvature and no 2 places are absolutely identical. The tiles are made of silica-based material with high porosity. This means that the tile weighs little, but it can withstand extreme heat. At the same time, the thermal conductivity of the material is so low that if you take a red-hot tile by the corner with your fingers, just a few seconds after removing it from the stove, you won't get burned. This was demonstrated by NASA engineers when creating the shuttle. The material is the same class. But SpaceX has redesigned the mount geometry and composition to increase resistance to shock loads when entering the atmosphere. The problem of thermal protection turned out to be one of the most difficult in the program. On the 4th flight, the cameras recorded the partial destruction of tiles in several areas. On the 5th and 6th flights, the situation improved. Engineers are constantly changing the geometry of the tiles, method of their fastening, and they introduce additional protection elements in the most loaded areas. This is an iterative process. SpaceX deliberately chose a strategy of rapid tests with real flights instead of many years of simulation. Because real data provides information that no computer model can provide. The Martian window that Musk is talking about is an astronomical phenomenon. Every 26 months, the Earth and Mars occupy such a relative position that the flight between them requires a minimum amount of fuel. This is called Hohmann transient momentum. During this period, the distance between the planets and the relative position of the orbits make it possible to complete the flight in about 7 to 9 months with minimal energy costs. If you skip this window, the next one will open in 26 months. The nearest suitable window for the first missions to Mars is at the end of 2026. That is why Musk calls this date. Not because the date was chosen arbitrarily. Because the physics of orbital mechanics dictates it. For the first Martian missions in 2026, SpaceX plans to send several unmanned Starship spacecraft with cargo. The purpose of these missions is twofold. First, to deliver equipment to the surface of Mars. Secondly, to confirm that the ships are capable of surviving a 7-month flight in outer space. Exposure to radiation, temperature changes, long-term operation of life support systems in autonomous mode. All this must be verified by real data before people are on board. The next Martian window after the 26th year opens in the year 2028. Musk calls it as a possible moment for the first manned missions. But to do this, you need to complete a huge list of tasks. The Starship must demonstrate stable reliability over many flights. Mechazilla should run like clockwork. The refueling system in orbit must be worked out. This is another critical technology that is less talked about. To fly to Mars, Starship is not enough just to launch from Earth. In order to gain the necessary speed for interplanetary flight, the ship must receive additional fuel already in orbit. This is called orbital refueling. The scheme is as follows. First, a tanker, a Starship version without a payload, but with a maximum supply of fuel, is launched into orbit. Then a Starship with Martian cargo or crew is launched into orbit. 2 spacecraft dock in orbit. Fuel is pumped from the tanker to the Martian spacecraft. After that, the Martian spacecraft has enough fuel to perform an acceleration maneuver towards Mars. The transmission of liquid methane and liquid oxygen in zero gravity is a non-trivial engineering task. Cryogenic liquids in zero gravity do not behave like usual liquids. They do not have a clear interface surface. Gas bubbles can form in arbitrary places. For reliable pumping, you need to create artificial acceleration so that the fuel collects at the intake hole. This is done with the help of small engines of the ship. A slight acceleration creates the effect of artificial gravity inside the tank. Fuel collects at the bottom of the tank, and pumping becomes possible. SpaceX has already conducted the first experiments to transfer cryogenic fuel in orbit during test flights. Let's go back to Mechazilla and its role in the overall architecture of the system. It becomes clear why this is not just a beautiful trick. This is a key element of the economic model. Musk says that the cost of launching 1 kilogram of cargo into orbit using a fully exhausted Starship should be about $100. Now the best indicator in the industry is the Falcon 9 with its cost of about $2,000 per kilogram. And in the 90s, this figure was $20,000 per kilogram. A 20-fold reduction in cost compared to the best modern indicators looks fantastic. But it is precisely this reduction that is necessary for sending humans to Mars to become economically feasible. And Mechazilla is one of the key tools for achieving this goal. Because fast return and restart of the stage without changing landing legs and without transporting between sites directly reduces the cost of each startup. Now about the risks. What happens if something goes wrong during the capture? The first scenario is a mistake of the manipulators. If the missile deviates from the calculated trajectory by several meters, manipulators will not be able to grip the mounting pins. In this case, the system must decide to go to a backup scenario, or an attempt to splash down in a predetermined area of the bay, or detonation by the emergency flight termination system if the trajectory becomes dangerous for ground targets. This is an emergency situation, but not a disaster. The infrastructure of the tower remains intact. The second scenario is uneven capture. If one manipulator grabs the pin and the other misses, the load will be distributed unevenly over the rocket body. With a mass of several hundred tons, this can create destructive bending loads on the structure. In this case, the control algorithm should immediately release the capture and proceed to the backup scenario. The software processes data from the force sensors in the manipulators in real time and is able to react faster than destructive loads occur. At least, this is how it is arranged in the project documentation. The third scenario is the failure of the onboard navigation systems in the final phase of the approach. If the missile loses orientation in the last seconds before being captured, the consequences could be catastrophic for the launch infrastructure. That is why the system is built with multiple redundancy of navigation systems, GPS inertial measuring units, optical guidance systems with landmarks on the turret. All this works in parallel and constantly verifies the data. SpaceX applies a philosophy that Musk calls rapid iterative development. Rapid iterative development. Instead of years of modeling and testing each component in the lab, the company builds real prototypes, launches them, receives data on failures, and he makes changes quickly. This is the opposite of how traditional aerospace companies and government agencies operate. NASA spent more than $20 billion developing the Space Launch System and more than 10 years before the first flight. SpaceX created the Starship in significantly less time and significantly less money. Although SpaceX does not disclose the exact cost figures, critics of this approach point out that the prototype explosions pose environmental risks to the Boca Chica area, and the fact that the pace of testing can lead to an underestimation of risks during the transition to manned flights. These are justified comments. FAA. The U.S. Federal Aviation Administration has repeatedly delayed the issuance of licenses for SpaceX launches precisely for reasons of environmental impact assessment and risk assessment. Delays sometimes amounted to several months, and this really affected the pace of the program. In parallel with the technical side of the program, there is also a geopolitical dimension. China is actively developing its own Martian program. The Chinese spacecraft Tianwen alone successfully reached Mars in 2021. By launching a satellite into orbit and lowering the Zhurong rover to the surface, it was a significant success. The Chinese space agency CNSA has announced plans for manned missions to Mars in the 30s. Russia lost a significant part of its competence in the field of Martian missions after the collapse of the USSR. The European Space Agency is collaborating with NASA on a program to return Martian samples. But ESA does not have an independent heavy launch system for interplanetary flights. Thus, The race to Mars is in reality a race between SpaceX as a private company and government programs, primarily Chinese. This is an unusual situation in the history of cosmonautics. Never before has a private company claimed to be a leader in the exploration of another planet. SpaceX's financial model is built on several sources of income. Commercial launches for NASA. These are contracts worth tens of billions of dollars, including a contract to build a Starship-based lunar lander as part of the Artemis program. Commercial satellite launches for third-party customers. Satellite launches of the Starlink system, which belongs to SpaceX itself. Starlink is a global system of low-orbit satellites for providing broadband internet access. As of the middle of the 24th year, the Starlink constellation consisted of more than 6,000 satellites. And this number is constantly growing. Revenues from Starlink, according to some estimates, amount to several $1 billion a year and are the main source of funding for the development of Starship. This means that every time a user pays for the internet through Starlink, part of this money goes to finance the Martian program. This is an unusual business model, but it works. SpaceX remains a private company with a valuation of more than $200 billion in recent funding rounds. What awaits the program in the coming years? SpaceX plans to increase the pace of Starship launches many times over. The goal is for the 2025th and 26th years. Reach several dozen launches per year. This is necessary in order to work out orbital refueling, confirm the reliability of the heat shield, test the life support system for long flights, and most importantly, ensure that Mechazilla is stable in high-frequency applications. In parallel, SpaceX is developing a version of Starship with an expanded cargo bay to deliver NASA cargo to the lunar surface as part of the Artemis program. The first manned landing on the Moon under this program is planned for 2026. And it is Starship that should act as a lunar lander. This will be the first real test of the system in an interplanetary flight. Even if not to Mars, but to another celestial body with real gravity and real landing conditions. If the lunar program using Starship is successful, this will be the most important argument in favor of the realism of the Martian plans. Because the lunar mission will work out most of the critical technologies. Landing on a celestial body without an atmosphere, crew work in low gravity, takeoff from the surface, orbital refueling, and of course, Mechazilla works under heavy load. Back to Mechazilla itself. It is important to understand that this is not the final construction. SpaceX is constantly upgrading the tower, adds new diagnostic systems, improves manipulator control algorithms. After each test flight, engineers analyze terabytes of data, identify weaknesses, and they make changes. Sometimes weeks pass between flights, sometimes for several months. It depends on the amount of necessary modifications and the speed of obtaining permits from the FAA. One of the little-known aspects of the program is the acoustic protection of the launch pad. When starting 33 Raptor engines at the same time, the acoustic energy is enormous. Sound waves can damage the structure of the missile itself and ground infrastructure. To absorb acoustic loads, SpaceX has developed a water supply system. At the moment of launch, thousands of tons of water are supplied under the launch pad. Water evaporates and absorbs acoustic energy. On the fifth test flight, the water suppression system was already working normally. And this was one of the factors that ensured the successful capture of the Super Heavy turret. The flight control system deserves special attention. Starship uses 3 independent onboard computers operating on the principle of voting. If one computer issues a command that is different from the other 2, his decision is ignored. This protects against single failures. The software is written primarily in C++ and is constantly updated between flights. SpaceX uses its own real-time operating system, which provides deterministic execution of control commands with a delay of no more than a millisecond. This is critical for the final capture phase, when the price of each millisecond is literally equal to the cost of the missile. Ultimately, Mechazilla is a concentrated expression of SpaceX's philosophy. Do what seems impossible. Do it quickly. Learn from mistakes. And not to stop. Catching a 70-meter rocket with giant steel arms seemed crazy. Until this became a reality in October 2024. Now this is a routine task that needs to be scaled up to the level of industrial reliability. Mars is not waiting. Orbital mechanics opens a window at the end of the year 2026. And everything that SpaceX does today, every launch, each grip, each modified thermal insulation tile, these are steps towards the moment when the first ship with people will leave Earth orbit towards the red planet. And Mechazilla will stand in Boca Chica, ready to catch the next missile.